Yo, what's going on, man? What's happening? So today we are going to master nodal analysis. So let's do that. As we can see here, we have a dependent voltage source, right? It's going from this is the high potential, positive is the high potential, the negative is the low potential, right? So this is going to be the high potential, right? So let's write that. This is the high potential. This is the low potential. Actually, I want to type it out just so I can still draw when I want to. So this is the high potential, and this is the low potential for the voltage dependent source. So let's do that. Alrighty. Now what I want to do. Alright. So I guess now we can start labeling points that we know. So obviously we know this is 0 volts. Right. Ground is always going to be 0 volts. What else we got? We're gonna have 100 volts across ground because that's a 100 volt difference battery, right? What else we got? And it doesn't look like we know anything else, but we can solve for other things. So we will do that in a second, right? So we don't know the voltage across this 120 volt battery, obviously, because there's nowhere where it's connected to ground, right? Or another way to think about it is there's nowhere it's connected where we know the voltage, right? We don't know the voltage here, and we don't know the voltage here. So therefore, we cannot figure out the voltage across this battery, right? We just know there's a difference of 120 across it, right? All right, so let's see what we can do now. Did I? Okay, I did not. So let me, don't say that. All right, let me see. So what can I do now? So first thing I want to do, right, is let's solve for our unknowns, right? So let's solve for IO, right? We're gonna solve for IO. So let's do that real quick. So IO, right? IO is going to equal, right? As you can see, we have the high potential here of VA. Ooh, actually, I didn't even label our essential nodes. So let's do that real quick. My fault, guys. So as you can see, we have VA here because we got 3 circuit elements, and we have VB here because we have 3 circuit elements, as you can see, and nowhere across this wire is there another 3 circuit elements besides the ground. So, all right, let me see. What do I want to do now? So we're gonna take the high potential of VA, right? So VA is all across this wire, right? And then we're gonna go through this resistor, right? And then Ohm's law gonna take effect when we do that, right? When we go through that resistor, Ohm's law is gonna take effect, and it's gonna produce a new voltage on this side of the wire, right? So let's see what we can do to get that, right? Because we need that for our IO equation, right? So let's label that voltage across that. We're going to label that Vx, right? This is going to be labeled as Vx, okay? Now, what does Vx equal? If we come over here to Vb, right? And let's pretend like Vb goes through the battery, right? So as we go from positive to negative, right, through a voltage source, we know that's a voltage decrease, right? So that's going to be a voltage decrease of the difference of the battery, right? Which is going to be 120 volts. And that will give us Vx, right? That will give us Vx, right? So let's write that down. So let's get rid of this for now. And we're going to do Vx is equal to Vb minus the voltage difference of the battery, right? And that's going to give us Vx, right? So now we can solve for IO. So let's do that. So we're going to have IO equal to VA, the high potential of VA, minus the low potential of Vx. And we know Vx is equal to VB minus 120. And we're trying to find the current across this. So we're going to divide that by 40. And that's going to give us IO. Now, just to make our lives easier, as we can see, this current source has a voltage gain of 2, right? So we're going to write this. So let's figure out what 2 times IO is, right? 2 times IO is going to be equal to 1 over 20 VA. So we're going to have 1 over 20 VA. Let's make that positive. Positive VA, 1 over 20. What else we're going to have? We're going to have negative 2 VB, 1 over 20. We're going to have negative, negative VB 1 over 20, right? And then we're going to have what? 124, that's going to be 6, right? So we're going to have positive 6 and positive 6, right? That is what that equals. 2IO is equal to that. I don't want to put a space there. I guess we'll fuck it. We'll do it. It's going to take up more room, but it makes it work look a lot more neat. Right. So we did that. All right. There was like a better way to have this. Yeah, I can't put it there. Yeah, we're just going to block some of the problem. All right. So now let's find VO, right? And we know VO, right? This is the high potential of VO. This is the low potential of VO. So we're going to do, what are we going to do? We're going to do VO, 3, VO is equal to VB minus the voltage difference across it. There's going to be the ground, right? VB minus ground divided by the total. Well, actually, we don't even have to do that because we're finding the voltage difference across, right? Because VO, this is dependent on the voltage VO, and this is what VO equal to, right? So now we're going to multiply VO by 4. So let's do that. 0.4. We're going to multiply VO by 4. Let's do that. So we're going to do 4 VO is equal to 4 VB, right? That's what 4 VO is equal to. It's equal to 4 VB. All right, so we solved for all our unknowns. Now we can start actually doing the actual, electrical work. So let me see what we're doing. Okay, we're doing good on time. All right, so we're going to do 0.0. Let's do that. All right, so first thing first, we're going to do this wire right here. I'm going to do that wire. All right, so let's do that. So we're going to find the current across that wire. So we're going to do VA minus 100 volts, or the difference of 100 divided by 10. All right, that gives us the current net wire. So we completed that. All right, so let's do the next one. So we're going to do VA. We're going to do VA minus the voltage difference across that resistor, which is going to be gain of 4 VO, and we know 4 VO is equal to 4 VB, so we're going to write 4 VB. Right? And we're going to divide that by 20, and that's going to give us the current in that wire. All right, so we're going to add another one, and we're going to do VA minus VX, and we know VX is equal to VB minus 120, right? And that's going to, and then we're going to divide that by 40, and we've completed that equation. So we've done everything here, so that's going to be equal to 0, right? We completed that junction. We know all the currents in that junction now. All right, cool. Now let's go to the next equation because we got one more essential node to deal with. So let's do that. All right. Put that here. Okay, so we're gonna have VB, let me see what we can do here. I guess we can do IO first. So as we can see, let's start from ground. Let's do that. So we're gonna go from ground into IO, right? So IO is gonna be IO2 with a gain of 2 is going to be a current decrease, right? Because we know it's opposite from battery. So this would be a voltage increase if it was a battery, but since this is a current source, it's a current decrease. So let's go ahead and write that. So we're going to have a current decrease of 2IO. And what is 2IO equal? So we're going to have negative VA minus, my bad, negative VA1 over 20 minus VB 1 over 20 plus 6. What is it? Plus 6. Yeah, this is plus 6. All right. So let me see what else we got here. Hold on. Before I continue, I want to see something. All right. Let's get back to solving our problem. We're going to have VB. Yep, so we did that. That's going to be the current there. Now we can do the voltage here, which is just going to be equal to VB. So we can just write VB. Actually, my bad, not the voltage here. We're going to do the current there, which is going to be VB divided by 80, right? VB divided by 80. And then we're going to do this here, right? So we already know what that is. That's going to be VB, right? So we're going to have VB. So hold on, just to clear it up. So we already did this, right? We did this. Now we have to do this, right? We have to do that. So let's do that. All right. It just, I guess, even cleared up more. So we're going to go from ground all the way through here, through here, through here, through all of this to VB, right? And again, we're just worried about the series circuit, right? So we're only worried about this part of the circuit, right? So let's do that. We're not worried about all this extra stuff down here because all this extra stuff is connected to VB in parallel. We're only worried about what's connected to VB in series. So let's go ahead and, oops. All right, let's go ahead and see what we can do here. So we're going to have VB minus 120. Because that's going to equal Vx, right? So VB minus 120 minus VA, right? And we're going to divide that by 40. All right, and all of that should be equal to 0. And now all we have to do is enter stuff into the calculator. So let's do that. All right, let me see. Where is my calculator? Here we go. Let's see how I'm doing on time. Okay, hopefully I'll be able to finish this in time. Let's see what we can do here. I probably won't though. All right, so we're going to have, what is this? We're going to have 1 over 100, right? 1 over 100. Oh, crap. I got to put it in fractions. Oh, yeah, there's no way I'm completing this. 1 over 100, right? 1 over 100. And we're going to have 1 over 100 plus 1 over 20 plus, what is it? 1 over 40. 1 over 40. And it's all, is that all our VA? It is. So we're going to have 17. So let's write that down. We're going to have VA, positive VA, 17 over 200. Let me just make sure this is correct. Oh, nope, that's not correct because that is a 10, not a 100. Well, okay. Let me see. What are we doing on recording? Yeah, I might as well go ahead and end it.